SANDHAN, All Gujarat Integrated Classroom.
સેટેલાઇટના માધ્યમથી જોડતી કડી એટલે સંધાન.
આજે આપણે મીન વેલ્યુ થિયરમ્સ વિશે ડિસ્કશન કરીશું. સ્લાઇડ નંબર 1. Myself, Dr. Haribhai Kataria from the MS University of Baroda. Next slide. Rolle's theorem. Here we will begin with a continuous function on a closed interval a b, and this function is differentiable on open interval a b. It also satisfies the condition f of a equals to f of b. Then there is at least one number in the open interval a b such that for that number the value of the derivative is 0. Now we will see the geometrical interpretation of the Rolle's theorem. See, if we have a curve y equals to f x which is continuous from a point A to B and has unique non-vertical tangent at every point on it between A and B, where the ordinates of the points A and B are same, that means f of A is f of B, then there is a point C on the curve between A and B having the horizontal tangent, and this is the figure for the geometrical interpretation of the Rolle's theorem. Here you can see that there is a tangent at a point C which is parallel to the x axis, and that is how it is the horizontal tangent. Next we will discuss the Langranges mean value theorem. In the previous theorem we will drop one condition. So, here the function is continuous on a closed interval a b, and it is differentiable on open interval a b. Then there is at least one number c in the open interval a b such that f of b minus f of a upon b minus a is f dash c. Now we will in this function my f is already continuous, and if you see the graph of the line y equals to x, it is a straight line. So, being a straight line, it is continuous. So, f is continuous, x is continuous, and therefore, my phi of x is continuous on closed interval a b. Moreover, my function f is differentiable on open interval a b, my x is also differentiable, derivative of x is 1, it is everywhere differentiable, hence it is differentiable on open interval a b also. So, my phi of x is differentiable on open interval a b. Now, I will find out the value of phi of a. Phi of a it is f of a minus f b minus f a upon b minus a into a. Now, we will simplify this. So, this is b minus a into f of a minus a into f b minus f a upon b minus a. If we simplify further, then this is b f of a minus a into f of a minus a into f of b plus a into f of a. So, this plus minus will cancel, and of course, here it is minus a into upon b minus a. So, the value of phi of a, it is b into f of a minus a into f of b upon b minus a. Similarly, we will find out phi of b, then this would be f of b minus f b minus f a upon b minus a into it is b. On simplifying, we will get the same value, that is b into f of a minus a into f of b upon b minus a. So, finally, what we find is my value of phi of a is the value of phi of b. My function phi is continuous on closed interval a b, number 1. It is differentiable on open interval a b, number 2, and phi of a is phi of b, number 3. It means that the function which I have considered, that is phi of x, it is continuous on closed interval a b, differentiable on open interval a b, and phi of a is phi of b. It means that my function phi satisfies all the 3 conditions of the Rolle's theorem, and therefore, I can apply my Rolle's theorem to this function. So, there is at least one number c for which the derivative at c is 0. So, now we will find the derivative of this function. It is differentiating with respect to x. This is phi dash x is, we have the derivative of f minus it is f b minus f a upon b minus a into 1, and therefore, the derivative at c is, it is f dash c minus f b minus f a upon b minus a. But as we are talking that this phi satisfies all 3 conditions of Rolle's theorem, and therefore, there exists at least one c on the open interval a b such that phi dash c is 0. Therefore, this value is 0. Therefore, 0 is, it is f dash c minus f of b minus f of a upon b minus a, and therefore, this f dash c is, it is f of b minus f of a upon b minus a, and this is the conclusion of the theorem, that if f satisfies all 3 conditions, then we will find at least one c in the open interval a b, where the value of the derivative f dash c, it is f b minus f a upon b minus a. Now, we will see the next slide. Now, we have some remarks on the Langranges mean value theorem. The first, it is the, this theorem is the generalization of the Rolle's theorem, means if you put f of a equals to f of b, then we may have the Rolle's theorem. So, Rolle's theorem is a particular case of the Langranges mean value theorem. The second remark is about the name mean value theorem. Here, if you see the conclusion of the theorem, it is f dash c equals to f b minus f a upon b minus a. Now, let us see what this f b minus f a upon b minus a represent. This is nothing but the average rate of change of f over the range closed interval a b, and if you see on the right side, it is derivative at c, that is nothing but the actual change in f at some instant. So, this average change is equals to the actual change at some instant, that is why the name is the mean value theorem. Now, we will see the geometrical interpretation of the Langranges mean value theorem. See, if we have a curve f x which is continuous from a point A f A to B f B and has unique non vertical tangent at every point on it between A and B, then there must be at least one point C on the curve between the points A and B at which the tangent is parallel to the chord AB. That we can see in this figure, that we have a curve which is continuous on the closed interval AB, and the curve is having tangent at every point on the open interval AB. It means my function satisfy both the conditions, and hence I have a tangent we can see at a point C on the curve, where the tangent slope of the tangent is equals to the slope of the second line, that is slope of the line AB, that is f b minus f a upon b minus a. Now, we will see some of the applications and some examples. My friend Dr. Ramesh Bhai will now present the solution of these examples in the board. So, you can see now the solutions on the board. The first example is f x equals to, he will write down f x is 2x square minus 7x minus 10, and he is considering the interval 2 to 5.
So, now you know Langranges theorem. So, that says that that theorem is applicable only when function satisfies those two conditions. So, here I have considered one function. As we know that this function being polynomial is always continuous and differentiable, because every polynomial function is always continuous and differentiable. So, here this being a polynomial function is continuous and differentiable everywhere. Here I have considered closed interval, therefore it is again continuous and differentiable. So, to use that or to find the value of c, first I will get the derivative of this function. So, if I differentiate this, here we will get the 4x minus 7, this is the derivative of this function. Now, as it satisfies all the conditions of that theorem, as it satisfies, Langranges theorem on this closed interval 2 to 5, we can find c. From open interval 2 to 5 such that f of b here, this is closed interval a b. So, here b is 5. So, f of 5 minus f of a, which is 2 here. So, f of 2 upon, we have b minus a, which is 5 minus 2, equal to f dash c here, for some c from open interval 2 to 5. This is what the statement of the theorem, that says that you can find one c from open interval 2 to 5 such that f of b minus f of a upon b minus a equal to f dash c. Here this is closed interval a b, so b is 5 and a is 2, so we are having this. Now we will simplify this further. So here f of 5 will be, this is nothing but the 25 into 2, so 50 minus, this is nothing but the 35 minus 10 minus f of 2 will be 8 minus 14 minus 10 upon 3, that is equal to f dash c here. So from this we'll get here, this is 45, so 5 minus, this is nothing but, this is minus 7, so this is 17 upon 3 equal to f dash c. F dash c you can write from this. So this is f dash x. So putting x is equal to here c. So we'll get the 4c minus 7. This is probably 10. So 24 minus this. I'm sorry.
Minus
So this is 16. So this will be 5 minus 16. So it will be minus 11 by 3 equal to 4c minus 7. So 4c will be 11 by 3 minus 7. So therefore 4c equal to, this will be 21 by 3.
That 16 would be plus 16 because
Oh,
minus
so
2.
this is minus minus gives you plus 16. Yes, I'm sorry. So this will be 21 actually. This is actually minus 16, so this is plus 16. So this is 21. So if you this will be 21 by 3 plus 7 equal to 4c. So this is nothing but the 21 plus 21 by 3 equal to 4c. So would be 42 by 3 equal to 4c. So we'll get the 42 by 12 equal to c. So this is 4 3s are, and here we have 14 3s are. So this is nothing but 7 by 2. The value of c will be finally 7.